All right, everybody, welcome back. This is going to be a great year. We're going to start with a review on right triangles, starting with Pythagorean's theorem. As you recall, the theorem states that the sum of the squares of each leg equals the square of the hypotenuse. So a squared plus b squared equals c squared. We're going to do a couple of examples, one where we find the hypotenuse and one where we find a side length. So for this problem, we're going to find the hypotenuse, so c. And as we recall, the formula is a squared plus b squared equals c squared. And so we just substitute that in with a equals 3 and 10 being b, and you get 3 squared plus 10 squared equals c squared. We'll just work that out. We'll get 9 plus 100 equals c squared, so 109 equals c squared. Now, we just want c on its own, so we're going to find c by taking the square root of each side. Square root of 109 equals c. Now, I know normally when we take the square root of each side, we get two answers, but we are talking about a side length, so we do not need the negative answer. Also, the radical square root of 109 cannot be simplified, but we will see an example of that in the next slide in case you need a refresher. Okay, so in this example, we're going to be finding a side length. It's a little blurry, but it'll work. That side is 6, the hypotenuse is 8, and we want to find this one right here. We'll call it x. So the formula is going to look a little different, but it's going to work the exact same. You get 6 squared plus x squared equals 8 squared. So 36 plus x squared equals 64. So we'll subtract 36 from both sides to get x squared equals 28. Therefore, x equals the square root of 28. And like I said earlier, we're going to simplify that radical, get a little extra practice in doing that. If you don't remember how to do that, we want to look at what perfect squares can go into 28. So recall the perfect squares: 4, 9, 16, and so on. 4 goes into 28, specifically it goes into 28 7 times. So you get square root of 28 equals the square root of 4 times 7. Now we can pull that 4 out. The square root of 4 is 2. And so the square root of 28 is the same as 2 times the square root of 7. And that is it. And real quick, we're just going to look at a 3, 4, 5 triangle. They pop up a lot. It's the most famous right triangle because it's 3, 4, and then 5, obviously, and 3 squared is 9, 4 squared is 16, and if you add those together, you get 25, which is 5 squared. So that's good to know, good to keep an eye on, because if you see one of these triangles, it'll make your life a little easier if you don't have to work out Pythagorean's theorem for the whole thing. Note that it also works for a 30, 40, 50 triangle, and 0.3, 0.4, 0.5 triangle. You can test those out yourself if you want. You will also see that 6, 8, 10 will also work. Okay, now we are going to work with a distance problem, and you might be wondering why we're doing distance in a conversation about Pythagorean's theorem, but you're going to find out that it is essentially the same thing. So we're going to look at the distance between the points 2, 6, and the point 5, 2. So we're going to look and find the distance or the length of that line segment right there. And if you recall, the distance formula is the square root of the square of x2 minus x1 and the square of y2 minus y1. So for this specific problem, we're going to get that the distance is 5 minus 2 squared plus 2 minus 6 squared, and then you take the square root of all of that, and you get, let's work it out. We get the square root of 3 squared plus negative 4 squared. Notice that's a 3 and a 4. That'll come back later. And you get 9 plus 16, which is 25. There. Whoops. Oops, sorry about that. Which is 25, and then you take the square root of it and you get 5. So that is the distance, and I'm going to show you how you can do it using Pythagorean's theorem. So if you take this all the way down, you get, and you can count this up, 1, 2, 3, 4. So that's a side length of 4, and this is a side length of 3. And that is a right triangle right there, and we just went over this. It's a 3, 4, 5 triangle, which means the distance is going to be 5. So that's how you can use Pythagorean's theorem to get the distance. The distance formula is essentially the Pythagorean theorem, and that 3, 4, 5 triangle makes it easy, so you don't have to do any more math than is necessary. And that is our review of the Pythagorean theorem. Next up, we're going to do a little bit of review on SOHCAHTOA and some practice on right triangle trigonometry. I'll see you next time.